Hey grade 12s and welcome to this video. In this video, we are going to be working on the Maths Paper 2, grade 12 from November 2022. Okay, so this paper is 150 marks and the time allocated to the paper is 3 hours. Now, I'm going to be dealing with these in sections because, as you guys have probably seen by now, it's actually best to deal with them in topics. That way, we can still compile different topics, for example, like algebra, and then make a compilation video of that so that you guys can actually just focus on studying algebra only and things like that. Okay, so in this video, we are going to be dealing with statistics, which is on questions 1 and 2. So, question 1 says, the matric class of a certain high school had to vote for the chairperson of the RCL, Representative Council of Learners. The scatter plot below shows the IQ, the intelligence coefficient, of the 10 learners who received the most votes and the number of votes that they received. Okay, so they've already given us a scatter plot, and as you can see, this is the number of votes, and that's the intelligence coefficient. Okay, and what they tell us is, before the election, the popularity of each of these 10 learners was established and a popularity score out of 100 was assigned to each. The popularity scores and the number of votes of the same 10 learners who received the most votes are shown in the table below. Okay, so popularity score out of 100 and their votes. So we have two things that we're really comparing. Their IQ with the votes and then the votes with the popularity score. Okay, so the first question says calculate 1.1.1, the mean of the votes that these 10 learners received. But I also want you to note that the second question asks for standard deviation. So in this scenario, you do not need to go take your votes and start counting them one by one. We can use the calculator to calculate this, okay, by using the stat option. Okay, so let's get into this. So on our calculator, what we're going to do is, on your calculator, of course, the Casio one, you are going to press mode. And when you press mode, you'll see some options. You just need to go for the option that says stat. So go for stat. Now, honestly, at this point, you can decide to either see this as a data set with one variable, meaning we are only going to take the number of votes into account. But this might be a waste. So you'd have to check the other questions to see what data specifically they're referring to. So here's what I mean. You see with the other questions that we have here, look at the type of questions we have. Yes, they ask for the standard deviation, okay, of the number of votes. So that still has to do with this number of votes. But then they also ask for things like the learners who receive fewer votes than one standard deviation. Okay, it's still dealing with standard deviation of the votes. So it still deals with this. And if you keep going on, you have to check, does it introduce any of these variables, the intelligence coefficient and the popularity score? So if we look, we see actually that there's one that actually asks for the least squares regression line, but they say for the given data in the table. So it is best to actually fill in both of these so that we can just like kill two birds with one stone, really, and just get through this quicker than we would have to. We don't want to have to put in information twice. So on your calculator, make sure that you go for option 2, the option that says A plus BX. Go for that option. And when you go for that option, you will see that you have two columns. So in the X, go ahead and put in the popularity score, and in the Y, put in the number of votes. And then once you have put everything in, you can press AC, Shift, and 1. And then you will get options. Now, remember, we are looking for the mean number of votes for these 10 learners, okay? So since we are looking for the mean number of votes, remember, the votes are in your Y values, okay? So go for the option that says VAR for variable, and then you're going to look for where you can see the mean of the Y values. It's going to look like this, okay? Make sure you take this one. Don't go to regression and take this. That is not for the mean. So take that and you will find your mean. So it's option 5 and your mean is 15.5. That's what it should be. So over here, I'll just go here, and as you can see, we will still have the mean as 15.5. There we go. Okay, so that is that. Moving on to the next question. The next question, 1.1.2, says we need to calculate the standard deviation of the number of votes that these 10 learners received. So again, that's going to be found in the variable. So we can say shift 1, and then we're going to find this in variable, and you're going to look for the standard deviation of the y values, okay? Because it's the votes that we're focusing on here. Okay, and that is over here. For you, it's going to be option 6. Okay, so the standard deviation of the y values is equal to, now I have to get rid of that because it's just going to multiply. So that answer is, as we can see, 4.59. Okay, so that will be the standard deviation. Okay, so that is the answer there. Moving on to the next question. Okay, 1.2 says the learners who received fewer votes than one standard deviation below the mean were not invited for an interview. How many learners were invited? Okay, so they're giving us information about the learners who were not invited, and using that information, we need to tell them the learners who were invited. Okay, so the learners who received fewer votes. Okay, so keep that in mind. But fewer votes specifically, let's just put that in red. Fewer votes than one standard deviation below the mean. So one standard deviation below the mean would work like this. You are saying a standard deviation lower than the mean. So where you have the mean, which is going to be like that, the mean of the y values, we're going to go a standard deviation below the mean. So it's mean minus standard deviation. Okay, so let's find out what exactly that would be. The mean was 15.5 and that standard deviation was 4.59. So what does that give us? So you can do calculations still normally on your calculator. If you say 15.5 minus 4.59, you're going to get 10.91 on your calculator. So this is one standard deviation below the mean, right? And they're specifically saying the learners who received fewer votes than this, that they were not invited, okay, for that interview, not invited. So let's think about it, fewer than this. So we're going to look at our numbers, right? The votes that we have, and we're going to look for values that are lower than this because fewer votes than one standard deviation below the mean. Okay, so let's find out how many votes are less than this, 10.91. So the votes less than 10.91 would be 9, 10, okay, because it's less than 10.91. 11 is not. All of these ones are just above it. So do you see that there are only 2? So we have specifically 2 votes that are less than this. So that means the learners who were not invited were 2 learners, okay? 2 learners were not invited. And so how many learners were invited? You know that there are a total of 10 learners, so it means that 8 learners were invited. Okay, so there we go. Moving on to the next question. The next question says, determine the equation of the least squares regression line for the data in the table. Okay, so the least squares regression line, you know that that equation looks like this. Y is equal to A plus BX. Okay, it's on the calculator. So we only have to look for the value of A and the value of B. And they said for the given data in the table, okay, for the data given in the table. So it's for this, which we've already recorded on our calculators. So all we have to do here is you can press AC, Shift and 1. Okay, I'm just going to erase that and press Shift and 1. And then when your options pull up, you are going to now go for option 5. Because option 5 is where we deal with things related to regression. Okay, so we're going to go ahead and go for regression option 5. And then you see your variables. We want the value of A, so go for option 1 and say is equal to, and we see that that gives us 1.77. Again, to pull up your data, you can just say Shift 1. You don't have to erase anything on your calculator. Again, go for regression, and then we're going to go for option B to find the B value. So B is equal to what? That gives us 0.22. Okay, so as an equation, this is just y is equal to 1.77 plus 0.22. And that is the equation of our least squares regression line. Moving on to the next question. Okay, 1.4 says predict the number of votes that a learner with a popularity score of 72 will receive. Okay, so remember, this obviously has to do with the what we just found, right? It is still dealing with this table. Okay, so with this least squares regression line, the popularity score, as you saw, were your X values. That's why all the other votes things were dealing with Y values. Okay, so if our equation is Y is equal to 1.77 plus, sorry about that, I didn't include the X. Okay, should have an X. So if it is 1 plus 0.22 in place of X, because they gave us an X value, the popularity score of 72, we'll just fill that in there. And you can still do normal calculations on your calculator. So let's find that answer. Okay, so that is going to be 17.61. Okay, now in this one, it is votes. I mean, you can leave it like that. It's still fine. Okay, because with the mean, we also left it the same. We also left it at 15.5 and so on. So I'll just leave it like this. This is our answer. This is the votes that we would get. Okay, moving on to the next question. Okay, 1.5 says, using the scatter plot and table above, provide a reason why IQ is not a good indicator of the number of votes that a learner could receive. Okay, I see that they say using the scatter plot and the table above, and we have 1.5.1. So this one is specifically related to the scatter plot because you see that it's speaking about IQ and the number of votes. That's really what was in the scatter plot, the IQ and the number of votes. It didn't include the popularity score. So using this scatter plot, right? Why is IQ not a good indicator of the number of votes? Okay. So as you can see, you see the way this data points look. That one is there, this one is there, that one is... There's no consistency at all. They're just random. They're scattered. So when they're scattered across like this, their correlation is pretty low. It's very low. Okay. And so because of this, there is no correlation. With something that actually has a correlation, you will notice that the data points will be close to each other. They would be following a trend, like, they could be increasing or decreasing, but they will be close to each other, not scattered across like this. So the main reason why IQ is not a good indicator, okay, for the number of votes that a learner could get is because the data points are scattered across, which suggests a low correlation. Okay, so the data points are scattered across, which suggests a low correlation between the IQ and the number of votes. So they're not related, which just means that the IQ does not affect the number of votes that the learners are going to receive. And 1.5.2, it says, so we have to, again, using the scatter plot and the table above, so this time it's probably the table that we're going to use, provide a reason why the prediction in 1.4 is reliable. Okay, why is this prediction reliable? Why is it that a learner with a popularity score of 72 is more likely to get 17.61 or 18 votes, really? Okay, so why is that true? That again is going to have to deal with the correlation. But you see that with the table, right, where we have to deal with the popularity score and the votes, it's a table. So we can't look at the correlation coefficient by staring at the table. We need the calculator to find that. So we're going to find R here, the correlation coefficient. Okay, so let's go ahead and find that. I have to erase my data first, and then shift and 1. And then your data pulls up. You're going to again go for regression option 5, and you will see an option that says R for correlation coefficient. And you see what the correlation coefficient is, 0.98. That is quite high. That is why this data is reliable, because you have a strong correlation. It's positive. Okay, sure, it's positive, but it's still strong. We don't care about whether it's negative or positive. The positive or negative doesn't really tell you about the strength. It just tells you the trend, okay? Whether your data points are moving upwards, so if they are, close together and they look like this, so they're moving up. And if they are close together but look like this, they're moving down. So our reason here is, why is the prediction reliable? Because there is a strong positive correlation between the popularity score of the learners and the votes. That is the reason why. Okay, because there is a very strong correlation between the popularity score and the votes of the learners. Okay, so that is it for question 1. And then we move on to more statistics in question 2. Okay, we are now on question 2. And question 2 says, a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel in a particular month. The data is represented in the ogive or the cumulative frequency graph below. Okay, so we have this and we have the percentage of salary on fuel and the cumulative frequency. Okay. The first question, 2.1, says, how many people are employed at this company? Okay, so remember it's a cumulative frequency. You keep adding on whatever the frequency is to get that cumulative frequency. Okay, so you add, you get that, and you add that to get that, and you keep adding. So the last number that you have would be the total number of frequency or total number of people that you have there. So where that would be found, because this is the cumulative frequency, it would be at the highest point of this frequency, which is, what is the last point that we have? It's this, and that frequency is 60. So that's the total number of people. There are 60 employees at this company. Okay, so that is it for the first question. Moving on to the next question. The next question, 2.2, says, write down the modal class of the data. Okay, so this question has shown up a lot when they only give you an ogive and you need to know the modal class. So you can think about how the modal class, remember, it has to do with the number that appears the most. But this is group data, so you would have information written down. I'm only explaining it like this because I actually still want you to know how it comes about. I could just give you the answer, but I want you to actually just see how it comes about. So where this all starts is because of this. Okay, that's actually the reason it's going to look weird. It's because of this. You see the first point, when you have your group data, so the X values, we'll just call them X values. And then you have, of course, the frequency and the cumulative frequency. Your X values are going to look like this. Now, because this is, as you can see, it's 5, and on the Y value, it's on 0, right? So here, X will be greater than 5. So people who have spent more than 5 Rand, but less than or equal to 10 Rand, okay? The frequency that is going to belong to this is not 0, okay? The one that takes the 0, the reason it takes the 0 is because you have 5 here. So with the ogive, when you're plotting it, the number that goes here, the number that is here, you pair that X value with 0 on the Y-axis. But it means that that frequency was actually whatever this is over here. Okay, like that. So roughly that's about, we have 2, 4. Okay, it's more than 4. Let's just say it's about 5. Okay, so that means those people would have spent, there would have been 5 people who spent between this amount. Okay, and then that amount will go to the cumulative frequency. So when you look at it like that, it means whatever frequency you have here, it belongs to numbers that are greater than this, but less than or equal to this. For example, we can also just jump because I'm not going to go through everything. Let's say this number over here, the cumulative frequency is about, so 20, 22, 24, right? It's about 24. It means that the class with a cumulative frequency of 24 was, if this is 20, then that class was the class that was greater than 15, but less than or equal to 20. Okay, so greater than 15, but less than or equal to 20. So now when you're looking at the modal class, remember that modal class comes from mode, the number that appears the most. These are all just classes. They've been put in groups. So the number that would appear the most, okay, we'll be looking at the groups. It will be really the group that appears the most, whether that be the group that spent greater than 5 but less than 10, or the group that spent greater than 15 but less than 20, okay? Despite the group it is, the modal class, right, depends on the number or the class that appears the most. How you know how much a class appears is based on its frequency. This class, okay, there were 5 people in this category. So where would your modal class be? If it appears the most, you're specifically looking for your highest frequency. Okay, so how you can spot the highest frequency in your ogive is by looking for the biggest jump. Okay, what I mean by the biggest jump is the biggest gap between your points. You see, between this and that, okay, where would the biggest jump be between all these points? You see that when you get here, that is the biggest distance we have between 2 points than any other points. So our modal class appears here. And so what does that mean? It means that the class, if this is the number that we're looking at, this is the point we're looking at, the class that belongs to is the class that is greater than 20, but less than or equal to 25. And then we can put that down. That is our answer. Okay, so this is a class that is greater than 20, but less than or equal to 25. And there we go. Moving on to the next question. Question 2.3 says, how many employees spent more than 22.5% of their monthly salary on fuel? Okay, so more than 22.5% of their monthly salary on fuel. Now I'm starting to realize that I've been calling these rands. They're not rands. They are percentage. So this is the percentage they use out of their full salary. Okay, so the employees that spend more than 22.5% of their monthly salary on fuel. Where is 22.5% of that monthly salary? You see that this is the percentage of the monthly salary. 22.5, yeah, it just seems like here in the middle, since it's in between 20 and 25. So 22.5 is this over here. And so if we check that, right, at exactly 22.5, how much people do we have? We have this amount of people, and now we just have to figure out what exactly that is. So this is 30, 32, 34. Okay, so 34 people here. But that is not our answer, because the question is how many employees spent more than 22.5. Grade 12s, they keep repeating these questions. Okay, so make sure you study these questions that you see being repeated. It's also going to be most helpful when I compile these videos as well, like I did with the question once, and make compilation videos of them, because you can just see each question individually and just see the types of questions that keep being repeated. Okay, so more than. It's not these people over here. So 34 people would account for everybody here, down here. And everybody down here is people who spent 22.5% and less. Okay, so everybody here, that's the 34 people. Okay, the total of 34 people are people who spent within this. We want the people who spent over this. So we would be looking at everybody above this. So how much people are here in that region? Okay, I can't really take 70 because it's not 70 people. So you'd have to think about it as, what is the total number of employees we have here? We have 60 employees. And we know that 34 of them, a total of 34, spend 22.5% or less than 22.5%. But we want the people who spend more than this. So we're going to take the 60 people minus the 34 people. And that will give us everybody who spends over 22.5% on their fuel. So that would be everything here. This is over 22.5, and the people that it relates to are all these people. That's my best way of showing you a visual explanation of that. Okay, so let's say 60 minus 34 and find that. So 60 minus 34, 60 minus 30 is 30, 30 minus 4 is 26. So 26 people, or employees, really, because employees. Okay, so it's 26 employees spend more than 22.5%. Okay, moving on to question 2.4. Okay, so question 2.4 says, an employee spent 2,400 of his salary on fuel. Okay, I like to put things down when I see that. The amount he spends on fuel is 2,400 Rand. Okay, in that particular month. Determine the monthly salary of this employee if he spends 7%. Determine his total monthly salary. So 2,400 is what he spends on fuel, right? And they tell us that this is 7%. So it's 2,400 over his total salary. He has a complete salary that he has, right? And we know now that this amount that they calculate, it is equal to 7% of his salary. because that's what 2,400 is. It's 7% of his total salary. So it's 7%. 7% is 7 over 100. So 7 over the total of 100. That's really the equation. 2,400 over x and is equal to 7 over 100. Okay, so we can find this by cross multiplying. You can multiply across like that. So that's going to give you 7x. And when you multiply these across, it's going to just, you see the number of zeros here, it's just going to be added here. So it's 2, 4, 0, and then 1, 2, 3. Okay, then divide both sides by 7, and therefore x is equal to, we can find the answer here. We can just put this back on because we need it now. Just put it back on. Yours will be comp. I just put mine on math. So 240,000 divided by 7. And that gives us 34,285.71 cents. And that's how much he earns. He earns that amount. That's his salary. Okay, moving on to the next question. Okay, the last question in statistics is 2.5. The monthly salaries of these employees remains constant, and the number of liters of fuel used in each month also remains constant. Okay, let's already put that down. I honestly feel like I've done this. Well, this paper, you would notice that Euclidean geometry of this is already up. It was up like 2 years ago already. That's because everything was already recorded. I edited Euclid and then I didn't edit this one. And then at that time, that's when my laptop stopped working and these ones were not up because of that. So that's why I'm just putting them up so that the compilations can be complete. So that's probably what I'm remembering. Okay, but possibly from another paper as well. Maybe this type of question was also there. But they are saying that the monthly salaries of these employees, okay, they remain constant. Their salaries, they're not moving, okay, which is already bad. We know something's going to increase, but their salaries did not increase. They did not get a raise. The number of liters of fuel in each month also remains the same. So they're still using the same amount of fuel, okay? So number of liters of fuel, still exactly the same, okay? Now the question is, if the fuel price increases from 21 Rand 43 cents per liter to 22 Rand 79 cents per liter at the beginning of the next month, how will the above ogive change? Okay, so it doesn't really seem as if they're asking you about the specific numbers, just how will the ogive change? So you see everything that stays the same. The salary, still the same, doesn't move. The amount of liters they use, still exactly the same. The only thing that changes is the price of fuel. Okay, so we're looking at the ogive, the price of fuel changes. This is how much they used to spend on fuel. What's going to happen is if the price of the fuel increases, because these are X values we're looking at, right? Higher values go to the right. It means that all of these single values, they're going to increase. So this will not be 5 anymore. It will be more than 5. This won't be 10. It will be more than 10. To be like here. And this one will be like here. So you see generally what is the ogive going to do? That ogive is going to shift. In what direction though? It's going to shift from where it is and it's going to shift to the right. Okay, because everything's going to be pushed this way since there's an increase in the price, in the amount that they are spending. The percentage of fuel is going to increase because their salary did not increase. So they will feel like we're spending more, which is true. They are spending more for fuel now because their salaries did not increase. Okay, so what happens to the ogive? It's going to shift to the right. So I'm going to just say that. The ogive shifts to the right. Okay, so the ogive will shift to the right because the percentage of salary spent on fuel will increase, since the salary did not increase. Okay, so that is it for statistics. And I will see you guys in analytical geometry.